So the first things we're going to look at here with the properties of logarithms are what are called the product and quotient rules, which say that if we have logarithm base b of m times n, we can split that up as log b of m plus log b of n. And then similarly, if we have division, log b of m over n, that becomes log b of m minus log b of n, where this comes from the product and quotient rules, or if you want to think about them, the sum and difference rules for exponents, that if we have something of form b raised to the power m times b raised to the power n with that same base, you can turn that into b raised to the power m plus n. And similarly, if we have b raised to the power m over b raised to the power n, that can be written as b raised to the power m, or excuse me, that should be a m minus an n. Let me add a bump and smooth a bump. It's close enough. I think you get the idea. Point is here that, again, with logarithms, we're just talking about exponential things where we specifically look at what goes on in terms of the exponents themselves. So we can write the sums and differences in terms of products and quotients, like so, where, again, as I mentioned in the intro, this section's all about the technical, mechanical stuff, so we're just going to get a lot of practice in here working with examples for these types of things. So for this, we want to use the product and quotient rules to expand log base 3 of 25, the natural logarithm of 4x, the common logarithm of 17 over x, and log base 2 of 7/8. Okay, so we got 4 cases here. We're just going to work through every single one of them. For our first one, we could note there that if we want to expand this using the product rule, we would need to know what we can split the value 25 into. Thankfully, 25 doesn't have a very complicated, what's the word I'm looking for here, factorization, where one of our options, it's not very useful, but if we really want to, we could say that this is equal to log base 3 of 1 times 25, or, using the product rule, log base 3 of 1 plus log base 3 of 25, where, very subtly, remember, anything with a 1 in those logarithms, log base 3 of 1, log base anything of 1, is always 0, because it's saying what power of our base is equal to 1. So hey, guess what? This definitely is just log base 3 of 25. Pretty slick, right? No, not really. Not that slick. So we'll do something a little bit more thoughtful here. Instead, we're going to note that the other way we can factorize 25 is as log base 3 of 5 times 5, which we can split up a bit more thoughtfully, a bit more meaningfully, into log base 3 of 5 plus log base 3 of 5. Because we're saying here, what happens when you multiply exponents? Well, that's the same sort of thing as adding them if you're working in terms of the same base. And we can do that same flavor of thing, I said that too many times, for our second example there, where we're taking the natural logarithm of 4x. In this case, there are a couple of different things we can do, but the easiest thing to note there is splitting off 4 and x is kind of obvious how you put those factors apart. And you'd have the natural logarithm of 4 plus the natural logarithm of x. And if you want to go even further here, you could take this apart again and write it as the natural logarithm of 2 plus the natural logarithm of 2 plus the natural logarithm of x. And I'm not always going to write the parentheses here as we go further, but just to keep things a little bit cleaner, I'm going to put them in for the first few. Or you would pull this together and say 2 natural logarithm of 2 plus the natural logarithm of x. And that hints at another rule we're going to see later. Just think to yourself, okay, split that apart. We can also write that as 2 squared. Does that mean we could pull down the exponents? And like I said, we'll get there. So, be patient. Anyway, this is what we could do for that one. And there are a couple different ways we could even write it. That's another important thing to know here with these logarithms, is that the more we work with them, the more we're going to recognize that there isn't just one single way to express something like this. There are technically an infinite number of ways we can write this however we really want to in terms of whatever factors we like. Usually there's only a couple that actually make sense in the context we're working from, but we've got options. We've got lots and lots of options, unlike with, say, linear terms, where you can make something that doesn't seem to do anything by adding and subtracting 0 or multiplying and dividing by 1. It's not always obvious. With this, you got lots of ways to do that same sort of idea that's a little bit, I don't know, cleaner, maybe? Yeah, maybe that's just me. But point is, we got lots of different ways to say the same thing now. It's kind of clever. Anyway, for our third one, we are looking at the common logarithm of 17 over x. So we're going to use that quotient rule there and just split it apart. Log 17 minus log of x, where again, we're playing the game. If you divide two things of the same base, you can write that as a difference of the exponents. That's what this does. It's just identifying the exponents in particular. So for our last case, if we have log base 2, I don't know what's going on with that g there, but that's okay, of 7 over 8, we could play the same game. We would have log base 2 of 7 minus log base 2 of 8. And we can notice in there that, well, log base 2 of 7, not super useful. There's no power of 2 that gets you 7. 7's a prime number. But log base 2 of 8 can be written as log base 2 of 2 cubed. And that is a little bit more useful now, because you can see here that we're asking ourselves what power of 2 is 2 cubed. And that's just that log base 2 of 7 minus log base 2 of 8 is really log base 2 of 7 minus 3. So again, these look very, very different to the untrained eye, but hopefully as you're getting more comfortable with logarithms, you'll see those connections there a bit clearer and understand that, yeah, all four of these represent the same thing, but maybe this one is a little bit cleaner. It tells you a little bit more about what you're looking at, what you might be looking for, or maybe that's just me. I don't know. I've seen this stuff more than you guys probably have, so I've got more ideas of where this stuff can go. That's okay. But the other thing you should notice here, the other thing you should pay attention to, is that in this guy, it looked like I could pull out an exponent. And in this one here, it looked like if I pulled out that 3 somehow, I'd be talking about log base 2 of 2, which is 1, so that should still just be 3. So hopefully, at this point, if you're paying a little bit of extra attention, you might think to yourself, hey, can you just pull out exponents? Because logarithms are about identifying exponents. If you multiply exponents that come together in that way, the answer is, yes, we can. And that's what we're going to do next, is talk about the exponent rule when we're looking at logarithms of things raised to a power that might not be in terms of the base.